Okay, section 3.4, found in your book on page 118. The objective of this lesson is to find an equation of a line, given its slope and a point or 2 points or its y-intercept, okay? Up until this point, the book has given us the equation, such as 4x plus 5y equals 10. The book has given us the equation, so we're given the equation. And from that, we need to find things about this line, okay? We can find the graph, we can graph it. We can find points on the graph. We can find its slope, okay? So they give us the equation, and from the equation, we're finding things out about that line, okay? Today, we're going to be doing it backwards. Today, we're going to be given this information, maybe the graph, maybe some points, maybe the slope, and we need to write the equation. So first we need to talk about some different forms of a linear equation, okay? So an equation that graphs a line. Okay, the most common form and the way we like to leave our answers, so we leave our answers in this form, is standard form, okay? Standard form, again, looks like this, ax plus by plus c, where a, b, and c are all integers. What I mean by that is there's no fractions. They are all whole numbers. Okay. So for example, this example I gave you up here, this 4x plus 5y equals 10 is in standard form. Okay, so we will need to rewrite our answers a lot of times back to this form, ax plus by plus c. So where our x and y are on the same side together and our c. Okay, and not always do we have it in standard form to start with, such as 1/2 x plus 5y equals 9. This is not in standard form because of this 1/2. Okay, so we can get it in standard form by multiplying both sides by 2. So then multiplying this by 2, I get x. Multiply this by 2, I get 10y. Multiply that by 2, I get 18. These two are what we call equivalent equations. They're really the same thing, they're just written in a different way. So this would be our standard form. Okay. Standard form is nice because if we all leave our answers in simplest standard form, all our answers will look the same. But standard form isn't very useful. To actually find the equation of a line, really these two are a little more useful. Okay. Here, point slope form. Point slope form relies on the fact that if you know a point, let's say x1, y1, and you know the slope. In this case, our slope is m. So if you know a point, so here's our x1, here's our y1, and if you know the slope, there's our slope, right there, our m. This form is very useful because if you know a point, again, this x and this y are variables, just like up here. This x and this y are variables. This x and this y are variables. This x and this y are variables. This x sub 1, y sub 1 are not variables. They're a point that we know, okay, an x sub 1, y sub 1. So if we know a point and we know our slope, this one is very useful. And really when it comes to forms of the line, point slope form is really the most useful, okay? If you know your slope and your y-intercept, so this one here, m is also our slope, but b is our y-intercept. And what do I mean by y-intercept? That's just a fancy word of saying where it crosses the y-axis. So where my graph crosses the y-axis, there's my b, and there's my slope. So this one's useful also, but not as useful as point slope. So this is point slope. If you know a point and your slope, you can use this. If you know your slope and your y-intercept, you can use this one. Okay, so let's go ahead and let's do some examples. Okay, so example 1, finding an equation in standard form. That's an important thing there. I want to write it in standard form. So that's my final answer, needs to be in standard form. Of the line containing the point for negative 3 with a slope of negative 2/5. So what do they tell me? The point and the slope. So I'm going to use point slope form. So the first thing is I'm going to write this down. Y minus y1 equals mx minus x1. Here is my x1 and my y1. This thing right here is my m. So now I just plug it in. So y minus y1, which is negative 3, equals m, which is negative 2/5, x minus my x1 is 4. Okay, so there's my equation of the line. Now all I need to do is get it in standard form. And remember, standard form looks like this. ax plus by equals c. That's standard form. It doesn't look like that yet, so I need to do some rearranging. So let's see. This simplifies to y plus 3. Let's distribute this. Negative 2/5 x plus 8/5. Well, I know in standard form I can't have any fractions, so let's go ahead and let's multiply both sides by 5. I chose 5 because that's what's in my denominator here. So then here I'd have 5y plus 15 equals negative 2x, multiply that by 5, plus 8. Okay, now I need to get all my x's to one side. Well, let's add the 2x over here with the y. So we'd have 5y plus 2x equals, my 2x's cancel. So I'm close. I got my x's and y on the same side, but I have my 15. So let's bring it up over here. So I need to do some rearranging. I'm going to put my x first, plus 5y, because that's what standard form looks like. And then I'm going to subtract the 15 from both sides. So then those cancel, so I'd have 2x plus 5y equals 8 minus 15 is what? Negative, fill in the blank, 7. So there is my equation in standard form. Really, we had the equation right here. This is the equation of the line. All of this stuff was just getting it in standard form. Okay. Number 2. Find an equation, again, in standard form of the line containing, here they just give us 2 points. Well, if you notice on the front, I don't have a point-point form, but I do have point slope. And if I know 2 points, I can find the slope. So that's the first thing I'm going to do is find the slope. To find the slope, I need to subtract y2 minus y1, x2 minus x1, which gives me y2. Well, let's see. Let's make this 0.1, 0.2. So 1 minus a negative 2 all over 5 minus 1. So this would be 1 plus 2, 3 over 4. So my slope is 3/4. So I know my slope, and I have a point. I actually have 2 points. You pick which one you want to use. Doesn't matter, you get the same thing regardless of which point. I'm going to pick the positive ones because I like positive numbers better. So I'm going to use y minus y1 equals mx minus x1. So y minus, my y1 in this case is 1, equals m, 3/4, x minus my x1 is 5. Again, you pick and choose which one of the points you use, and you only use one of them. So I used this one to put in. You could have just as easily used this one. You'll get the same thing. Okay, let's distribute. Well, I've got the equation of my line now. This is the equation of my line, but it is in point slope form. I want it in standard form. So now I need to rewrite it. So y minus 1 equals, let's distribute, 3/4 x minus 15/4. Again, let's get rid of our fractions. So let's multiply everything by 4. So I'd have 4y minus 4 equals 3x minus 15. Okay, we still need some finagling to do. I need to move, let's subtract my 3x to the other side. So I'd have 4y minus 4 minus 3x equals negative 15. Now let's take this negative 4 and add it to the other side. So I'd have 4y minus 3x equals negative 15 plus 4. I'm skipping a few steps here. If you get confused, write them all out. So then if I rearrange this, my 3x is negative, so I have negative 3x. My 4y is positive. Make sure you don't lose your signs on these. Equals negative 11. Okay. Normally we don't like our leading coefficient. We don't like the thing on our x here to be negative. Right now it's negative 3. So I'm going to multiply both sides by negative 1. So I'd have 3x minus 4y, if I multiply by negative 1, equals 11. There is my standard form. Again, we don't like this thing on the x to be negative. We don't like a from up here. We don't like this a to be negative. So we always do our finagling to make it positive. Okay. Number 3, find an equation, again, in standard form of the line having a slope of negative 2 and a y-intercept of 4/3. So they give me the slope and the y-intercept. So which one can I use? Here I can use my slope-intercept form because I know the slope and my y-intercept. So the slope-intercept form is y equals mx plus b. This here again is my m, and this here is my b. Oh, sorry, this is my b. M slope, b y-intercept. So I can just plug in y equals my m, negative 2x plus 4/3. Okay, let's see. Should we add the 2x to the other side? So we'd have y plus 2x equals 4/3. If I rearrange 2x plus y equals 4/3. Oh, but we don't like fractions, so I have to multiply both sides by 3. So then my final answer here would be 6x plus 3y equals 4. Standard form. Okay. Jot down any questions you have on these 3 examples. Okay. Do your best to attempt every single one of these problems. They're all very similar to the examples, and come to class ready to discuss. Good luck.